Hey, what's shaking, sports fans? Today's topic is abstract rational equations, also sometimes called multivariate equations. So these seemingly simple problems are designed just to assess whether or not we can do algebraic manipulations. So there's no numbers involved in any of these. So let's look at four examples. Got four examples for you. Let's get right into these. Here is the first example. So called solving multivariate equations. Some algebra books will call them abstract rational equations because there's no number that you're solving for. You're not going to, for example, find m. We're going to find out like m equals 3 or something like that. We're going to solve for m in terms of the other variables in the equation. And the way it's presented, 1 over x plus b over m equals c, we cannot divide by 0, so naturally x and m both cannot be 0. So whenever you see a rational equation, that means one that has fractions in it, like these fractions, the first thing we want to do is find out what is the least common denominator. So my least common denominator, here these are all relatively prime. They're letters, so x times m would be my least common denominator. And what we do is we try to clear this of fractions. So I'm going to multiply both sides of this equation by xm, the least common denominator. So we're allowed to do that, right? We're allowed to multiply by the same thing on both sides of an equation. So then when I go to distribute this, on this first term, we're going to have just m because the x's are going to cancel out, right, with this x. And then I'll distribute to the other term. And I would have, this time, m's canceling out. So I would just have plus bx. And that would still be equal to all this stuff, cxm. So that's the result of trying to simplify this, get rid of the equations, make it a little bit easier to solve. All right, when you have these multivariates, the next thing you want to do is get all of the m's together, because that's what we're solving for, is we're trying to find m. So I'm going to subtract m on both sides. So that's going to move it from here. It's a plus on the left. It's going to be a minus on the right. So let's go ahead and do that. So that would give us bx equals cxm minus m. So the rationale for doing this is now I can factor m out. So I'm going to factor m out of this expression. So still have a bx on the left, and then m, that would be cx minus 1. So we can go ahead and check that, because if I multiply m times cx, I have mcx here. And if I multiply m times 1, I have an m here. Quite often, students will forget this. Sometimes I will forget this, to put this 1 here, but that needs to be there. All right, so next, all we have to do is divide both sides by cx minus 1. Because I want to know what m is, but m is being multiplied by this. So it's just like any other equation. We're allowed to divide by the same thing on both sides, except 0. All right, so here, cx minus 1 cancels. So the final expression solved in terms of all those other variables, b and x and c, is bx over cx minus 1. So this confuses a lot of students in the beginning, because you're not getting an answer. You're just solving an equation and saying, well, m equals 10 or something like that. But it's just solving in terms of all the other variables for m. So it's practicing our algebraic manipulations. So that's the first example. So let me know in the comments down below if you have any questions, and I will move on to example number 2. All right, so example number 2 here. Looking at this equation, we want to solve for b. Just erase part of my b. So I want to solve this for b. So I see a b here in this denominator, and there's a's and c's and d's and x's. So it looks kind of confusing, but just remember we want to try to isolate this that has the b. But our first step, as always, is, well, first recognize that b and d cannot be equal to 0 because right here we can't divide by 0. It's undefined. So the next thing I'll do is same as the first equation, is find out what the LCD, or least common denominator, is. And with these ones, it's easiest just to multiply your denominators together. You got a D and a B and D. So multiply by BD. So I'm going to multiply both sides of the equation by BD. And maybe I will go ahead and distribute this here. That will make things a little bit easier. So in this first term, this is the first term, notice that our b's will cancel. So that leaves us with just an a times a d. Oops, I just erased part of my, this is bd. Goodness gracious, Mark. Little mistake there. So b times d. Try that one more time. So b times d, the b's go out, and we're left with just a times d. So a times d, I write it right here, ad. Going to the next term, I see that my d's will now cancel, because d divided by d is 1, and 1 times anything is the anything. So we're going to have b times c. So let's go ahead and write that down, b times c. And over here, there's no canceling because the denominator was 1. So that's just xbd. All right, so again, notice we're solving for b here. So I see a b in this term and a b in this term. So I'm going to get these b's, the b terms, together. So I have one already on the left-hand side. So to get rid of this one, I'm going to subtract it. That'll get rid of it on the left, and it'll move it over here to the right. So minus bc. And now, again, same strategy as before, I can factor a b from this expression. So let's do that. AD equals b times xd minus c. So when I do that, I have bxd here. This is what I had here. And then b times c was what we had here. So now we're home free just about. Let's go ahead and divide both sides by xd minus c. So xd minus c cancels on the right hand side, leaving us with just our b, and the final answer is b equals ad over xd minus c. And that is the end of example number 2. If you have any questions, go ahead, put those down in the comments below, and I will move on to example number 3. All right, so here's example number 3. Hopefully you're getting the hang of these by now. So rational, I have to multiply both sides by the LCD. Oh, and of course b and x can't be equal to 0 because, as you know, we cannot divide by 0. So I'm going to go through and multiply everything by my lowest common denominator of bx. So, in the first term, notice, this is why we do this, it gets rid of one of our variables. and that means I have a times x. So in the next term, notice nothing will cancel here because that's just got a denominator of 1, so nothing cancels with b and x. So that just becomes, let's see, I'll write them in alphabetical order because I'm a little bit monkish like that. And then that is going to be equal to, on the right hand side, x's go out. So that's db or bd, if you want to write them in alphabetical order. You don't have to write these in alphabetical order. It just makes it easier when you're trying to sort for what you're solving for. In this case, we're solving for an x. And we're lucky here. So the x's are both on the same side of the equation already. So all I have to do is factor that x out, or undistribute it, if you want to call it that. So that would give me an x times a minus bc. And over here on the right hand side, nothing happened there. So the last step to solve for x is being multiplied by a minus bc. So I'm going to divide on both sides by a minus bc. So these cancel out. And the last thing we have is x times 1, which is in a different color now, x. And that would be bd all over a minus bc. So this is your final answer. So there's example 3 for you. Let me know if you have questions. Just write them in the comments down below. Okay, so here is our 4th example. I have an eraser going on. I have a over x minus y plus m over n equals k. So I want to solve this for x. So I need to get there's only one x in it, but x is going to be equal to something that has an a, y, an m, an n, and a k in it. So there's a lot of stuff going on here. So naturally, again, can't divide by 0. That's why this is written in the problem. And then I figured out that x times n, and I'll write it in alpha order, and x is going to be my least common denominator. So multiply every term times nx. If you notice, I've taken to multiplying, distributing this on the fly. And then this gets multiplied also by nx. Now let's go through and see what happens, what falls out. X over x, that falls out. Notice again here, I have a denominator of y, so nothing's going to cancel. Here my n's will cancel. And the k was also over a1, so nothing cancels there. So we're left with an, or na if you prefer, times nxy plus, let's see, mx equals knx. All right, so I've cleared the equations. I've cleared the fractions rather. Gotten rid of all the fractions. So this is looking a little bit nicer. So I want to find x. So I have this term has an x in it now, this term has an x in it now, and this term has an x in it now. So I'm going to move all of these to the same side. So we just have an equals, see, knx is already on the right hand side. And then I'm going to add this term right here. So nxy, right? Change the side, change the sign. Maybe you've heard that before too. Negative on the left, positive on the right. And then minus mx. So we're moving this to the right hand side. Now notice I have x. So when I factor an x out of this, or undistribute an x from this, x times a times n equals k. Well, I don't want to start with the k. I'm going to undistribute my x. So I have kn left. Let's say n and a y left, minus m. Okay, only the m is left because I factored the x out. Now we're home free because all we got to do is divide both sides by kn plus ny minus m. And we have our answer for x. So let's do that. I'm just going to do it on the fly for this fourth one since this is our last one. And I think you're getting a hint of it or the idea of it. So kn plus ny minus m. So this is your final answer. Didn't box the other ones, but sometimes teachers like you to circle the answer or something. So anyway, there's 4 good examples for you on rearranging or solving multivariate equations. And all it is, it's nothing more than practice for later on in your Algebra 2 and pre-calculus and even calculus classes. All right. If you have any questions, go ahead and hit me up in the comments down below. And also consider subscribing. Totally appreciate that. Until next time. So I hope you got some value from that. If so, I'd really appreciate if you would hit the like button. And as always, don't forget, math is not a spectator sport. The only way to learn math is to do math. Till next time.